All right, so today is the 1st of November already. How did October disappear? Okay, so we are continuing with, or actually wrapping up Unit 3, our Introduction to Programming unit. The Lesson 8 from this unit is the last assignment for the quarter, the last grade. So you need to get that in between the actual due date of the 8th and the last day to hand things in, which is Wednesday. That's more than enough extended time. So there aren't going to be any, I didn't get it done in time, grade change after the quarter. So get your work in. And yeah. All right, so lesson 10 on code. I guess you can just go to it right now. I don't really need to do that much. It's not going to be like a tutorial walkthrough. It is a project that you are going to create your own work. If you look at, and you will need to go to the spreadsheet to get the copy of the planning worksheet. And you're going to complete this and submit it. You have a couple options for submitting it, but let's talk about the project in general. The rubric is also on here. You don't need a copy of the rubric. You can just look at it. All right. So the project is going to be your own version or your own original digital scene. Similar, very similar, but not the same as the under the sea scene, where you're going to create some sort of, not necessarily landscape, there are other options, but that type of thing that has multiple different components. But the key is the idea of abstraction and random numbers. And you are going to demonstrate your ability to use these. They don't have to be super complicated. I'll do a demo of one, but that doesn't mean copy it. I think there was some confusion in the past of me doing a demo for some scene and then people just copying it, which is clearly not the point. But the idea is you are making a scene that has abstraction, multiple layered components, just like in the under the sea scene, we had draw seagrass, but we also had draw all seagrass. And the draw all seagrass sent a parameter to draw seagrass. Well, when you called the draw seagrass, it sent a parameter, which in this case used random numbers, to the lower level function, okay, using a loop. It was pretty basic. We did, 5 different components here. Your project only needs to have 3 or more separate complex components, plus a background. Background, back. I can type, I promise. Background / ground. Okay, so some examples that I have done or other students have done. Let me see. This one is not awesome, but it meets some of the requirements of these cacti, balloons, has random things. This one is pretty impressive. It is a bridge, obviously, that receives a random location for the moon, a random location for the stars, and actually a random height for the bridge and for the mountains in the back. Okay, this is all done with dots or turtle movements. What is this one? Okay, flowers are not terribly difficult. Guys, I need you all to be quieter. Okay, you'll have plenty of time to talk in a second. One that I've done that actually I put movement into it. You don't have to have movement, but this one has a, once it loads up, you will see it has multiple planes that point to a random direction, or positive or negative. I can show you how to do that. The sun, and I think once you click, it actually goes down. You don't need to have a timed loop that will make the position of something go downward, but it's essentially hitting refresh, except the sun is in a new location every timed loop. And just let's see how this actually runs. Okay, the sky, I guess the sky is probably first, which is just going to be horizontal, really wide horizontal lines where you have the move to XY way off the screen and draw across. And you sort of work your way forward. And this, I think, is probably way more complex than I expect. Well, it's definitely way more complex than I expect, but the concepts are the same. I just flew through it, but having, well, let's just look at the rubric for a second. All right, so at the top, you need to use comments in your code. Okay, comments are and this one doesn't have the comments. Comments are the lines of, well, not really of code, the lines of text that are there to help you remember what you were doing at that point, or have somebody else look at it and understand what your code is supposed to do. You can get that from one of the blocks, or just switch to text and do / / twice. That is a comment. Okay, so you need to have comments. You need functions that have functions, and parameter names need to be meaningful and descriptive. Okay, the key to this is the abstraction, the top-down design, the idea of layers. Okay, draw all fish uses the lower level function draw fish. You can wrap the entire scene in a function called draw scene, which would call all of the draw all functions, and so on. Okay, you need at least one function that has a parameter that works. You need to use multiple loops, which we all did the under the sea, and there was a loop inside of every higher level function. That's how you get multiples of something and also pass random numbers to their parameters. You need at least one example of a random number range using a logical way, which again, in the under the sea, we did random number in every single function. And the final sort of overall idea of complexity is you need at least 3 separate multiple level functions. Now you may have one function that's draw a background. That's not it. That's just the setup. A multi-level function or component is like the draw all seagrass. The seagrass from the under the sea is one multiple level component. It is a higher level function that uses a lower level function to simplify it. And that is it. Your first step for this is the planning guide. You are going to make a copy of this, and everyone always hands in their own work. This is also a solo project. Everyone is handing in, completing different scenes. You can collaborate, but you aren't handing in the same thing. And if you do hand in the same thing, you can split the points if you want, but That's not really a good use of your time there. So the planning guide, which again repeats a lot of the things you need to do. Your goal here is to first describe what your scene is. For sketching, I mean, I guess you could open this document and do some like draw on the screen, but you're probably better off sketching with actual pencil and paper. Take a picture of it, figure out the best way to insert it into the document. That is the ability to get a photo from a phone into a Google Doc via emailing and download and inserting. That is a very, very useful skill. If you don't already possess it, that is a good thing to learn. And you are deciding on what are your components. Okay, let's get rid of that because that's not the case. You are here naming just the top level functions, okay, as in draw all fish, draw all seagrass, draw all bubbles. This is what you say where it is, what it is, and this is where you give it its function name. You know, starting with a lowercase letter, no spaces or punctuation. Camel case is nice, and ends with 2 parentheses. That's how you know it's a function. All right, so you're going to complete this first. There is a likelihood that many of you, or I should say it was common in the past, so likely in the future, that students plan something, they get to the actual scene and try to code it, and it's either beyond them or it just doesn't work out, or they want to do something to go in a completely different direction. That's fine. You don't need to come back and change it. I want something that is at least a plan moving forward so that when you get to the coding of it, you can you actually have something to build off of or to start with. This is one of the first times that you guys get the chance to do original programming, original coding, and some students really take to it and just go all out and come up with really great ideas and use new tools that they haven't done. Great, go for it. But you need to get something done and it needs to be original. And I suppose I'll probably do a demo. And if you need help with something like how would you draw a flower, I can probably do a demo of something. I'm not going to give you the code, but I'll do a demo and explain sort of at least one way of doing it. Question? No, this is not a group project. You said for the whole group? No, this is a solo project. There are a couple places in the documentation, in the documents that may say group or share. Nothing about this is shared. Every step of this is an original project or a solo project, okay? You'll be fine. It's better overall. Okay, any questions about the assignments? So I don't have an assignment on gradebook yet for you to upload because of the whole quarter thing, and I could try to figure it out, but still do the planning worksheet. There will be a place for you to hand it in probably by next time. And we are going to spend 2 days on this, why did I get rid of the other thing? I don't like this over here. Let's just go like this. Like this. Okay, and for code, you can go straight to bubble 4. So this app originally is designed for pair programming, which we are not doing. Please, guys, just like 2 more minutes. And the idea, well, there's a lot of other things about the performance task project thing, and they're trying to tie it in. We're going to table those. We're going to postpone those. But the other bubbles for this, you can skip. They are, the first one would be if you were doing pair programming, you would do your own section and then share and copy and put it into your final situation, but you can go straight to bubble 4 and make sure when you are done, which again, we're gonna have all this class and all next class, that you hit submit when you're done so that it gives you a save that I can check. All right, any questions? Question? All right, start with the worksheet and get to work.